Bell ringer question 1. Is there a reason y'all are talking while I'm teaching? What is that reason? Okay, you're not going to need your computer today, so you can go ahead and put it up. Shh. You won't need your computer today. Okay, solve the following system of equations graphically on the set of axes below and state the coordinates of the solution. Quick reminder, Friday we're going to have a quiz, not a test, a quiz on, it's going to be graphing systems of equations. All right, so we're going to have a quiz on this. All right, so y'all said we graph the y-intercept first. So in this first equation, what's the y-intercept? 6. So and since it's the y-intercept, we put that on the y-axis. What's my slope? Negative 1/4. So what do I do from Jamaica? You asked me about this. Do you want me to go through it with you? Yes. Okay, so we plotted the y-intercept first, which was 6. And now with my slope, what do I do? Down 1 and to which way? Left or the other left? Right 4, okay. Because your slope is rise over run. So your rise in this one is a -1 and your run could be 4. Now, if you're out of room, you can do a rise of a +1 and a run of a -4. You can do that. So if I went +1 and 1, 2, 3, 4, 1, 2, 3, 4, I would still be on that same line. See that? Okay. Now, I don't have a ruler. I hope you all do. They're in the bottom drawer there if you need one. So let me try to do this way. Why am I doing that? It's on the rectangle setting. Huh? It was on the rectangle setting. Oh, okay. Yeah, I had it on rectangle. Now I can't see. Okay, thankfully it went through. Now this one, my y-intercept is what in the second equation? -6. And then my slope is 5/4, so I could do what? Up 5/4. Let me see. 1, 2, 3, 4, 5/4. 1, 2, 3, 4, 5/1, 2, 3, 4. So it looks like I'm gonna intercept right there. I'm gonna draw my line a little longer so they can intersect. Well, and then let me do this line. And you see where they intercept right there? This is my solution right here. So that's at 8, 4. I went over 8 and then 1, 2, 3, 4. It would be more accurate if I had a straight edge. You can I'll leave. Well, you'll do it on Delta Math Mars, so you won't need a ruler. But if you do it by paper, always get a straight edge. If I forget to give you one, remind me. Okay. So now let's look at this one. What is my y-intercept in this first equation? Okay. What is my slope? Okay. Okay. Wait a minute. I don't think I did that right. Okay, there we go. Now the next one, what is my y-intercept? 2, and my slope is a -2/5 down 2/5. Great, that one does. You didn't see what I did? Your y-intercept is 2. Oh, yeah. And your slope is a negative 2 over 5. So I did a rise of a negative 2 and a run of 5. So I started at 2, my rise, count down 2, and then over 5. Right here, that is my interception. So that's where x is 5 and y is 0. So that is my answer. The answer to a systems of equation is always an ordered pair. Yeah, I got 5 zeros. Yeah. But that was like without. So yeah, great. All right. We'll turn those in at the end of class. Now, come on, Soraya. No. These are my 6th graders. I told you. If they leave their notes, I'm going to throw them in the garbage. Let me pause this for a second. Okay, so let's be quiet. Middle table. Shh. Thank you. Thank you, Soraya. So in this lesson, the learning objective is over there. And what it is that we'll be able to determine the number of solutions to a system of equations. So what we've done so far has been one solution. That's where the lines intersect. That's a one solution. There are times when the lines don't intersect at all. That would be a no solution. And there's a time when the lines are on top of each other, and that would be an infinite solution. Okay? So parallel lines would be a no solution. So let's look at the 3. 2 or more linear equations form a system of linear equations. Any ordered pair that makes a system true is a solution. That's what we've done so far. If we had put those 2 numbers and ordered pairs into those both equations, we've got both equal on both sides. We've got an equality on both sides. So this is how a one solution looks like. This is what a one solution looks like. Right here, where the lines intersect, that is one solution. Your solution is right there where they intersect. Okay, now infinitely many solutions. This is actually 2 lines. One line is on top of another one. You got the red and blue. That makes purple. This is a no solution. That means your lines are parallel. We've gone over this briefly, but I wanted to spend a little bit more time on it today before we get to solving by substitution. Okay, so we're going to determine if each of these systems has one solution, no solution, or infinitely many solution. I can look at this one and tell you it's a one solution. Why? Because the slopes are not the same. I know it's a one solution. If the slopes are different, it's a one solution. Let's go ahead and graph it. So my y-intercept is 3. And my slope is a negative 5 over 3. So I'm going to count down 5. 1, 2, 3, 4, 5. And then over 1, 2, 3. And then draw my line. Hopefully, I will draw it correctly. No, I did not. Nope, that's not going to work. I'm just going to start from here and go to... I'm struggling over here. Okay, if I have to draw them longer, I will. Okay, now this one, negative 3. And my slope is 1 over 3, 1, 1, 2, 3. Ooh, thankfully, they went right through there. So I don't have to tell what the solution is. I just have to tell how many solutions. So it intersects in one place. So how many solutions do I have? 1. So this is a one solution. This one is going to be a no solution. How do I know that right off? They have the same slope, but look at the y-intercept.
It's the same number, but it's like different.
One is positive and one is negative, right? This could be a 2 and this could be a +3. It would, if the y-intercepts are different with the same slope, you got parallel lines. And we'll get to parallel lines somewhere after this lesson. I don't know exactly when. So we got a +2 for our y-intercept, and my slope is a -2, so down 2 over 1. Draw that line.
Oh, you want us to go?
Mm-hmm. This one, y-intercept is -2. Slope is down 2 over 1. And so these lines never intersect. That's what a no solution looks like. But I want you to get to the point of when your equation is in slope intercept form, you can look at it and tell. If your slopes are different, you're going to have one solution. If your slopes are the same, if the y-intercepts are the same, then it's infinite. If your y-intercepts are different, then they're parallel lines and they have no solution. And you can look at your equations. So how to determine the number of solutions using algebra? One solution, different slopes. Okay? So if the slopes are different, you don't have to do anything. One solution. Infinitely many solutions, it's going to have the same slope and the same y-intercept, meaning your lines are identical. They have identical equations. And then no solution, same slope, underline this. Different y-intercept. Underline it, circle it, highlight it. I'm going to highlight it because I cannot draw straight on this. So it's going to have the same slope but different y-intercept. And I'm going to give you a prelude to the lesson on parallel and perpendicular lines. These are parallel lines. You know, like 72 and Madison Boulevard, they both go east to west. They are parallel. They never intersect. So that would be a no solution. But County Line and 72 would have they have an intersection. That's where your solution would be, at that intersection. Okay, let's look at these. Are the slopes the same? No. So what is it? One solution. And if you don't remember what you're looking at, just kind of highlight your slope. I don't like that color for slope. It's not showing up good. What's the what? The symbol for what? Oh, your one solution would just be an ordered pair. Yeah. Now let's look at number 2. Donovan, are the slopes the same in number 2? Okay, what about the y-intercept for both these lines? Are they the same or different? Okay, so how many solutions would that be? There would be a no solution. Thank you for helping him, Gary, because he wasn't paying attention. And the symbol here, Leah, you can do that. Mm-hmm. Now let's look at number 3. What about that one? One solution, because the slopes are different. We don't, in this lesson, we don't even care what the solution is. Now, what about number 4? Trick question.
Infinitely many solutions?
Are both the slopes the same?
No solution. Oh, it's no solution.
Are the slopes the same?
One solution. Oh, it's
no,
one solution.
That's a one solution, right? That was tricky because this one is a 4 and this one is a -4. Now, if
same number, but it's still different.
Yeah, they're opposites. So you're going to have one positive slope, one negative slope. They are going to intercept. If the slopes were exactly the same, both of them positive or both of them negative, then it would be infinite. What about this one? No, so good. Now, This is what y'all are going to be asking me once I make the assignment. If both lines are not in slope-intercept form, put them in slope-intercept form before determining the number of solutions. So slope-intercept form, remember, is y equals mx plus b. Pay attention. And I'm going to tell you the reason that you have a hard time doing your assignments is because you don't pay attention when I'm teaching. You need to pay attention. Because your friend you're talking to, they can't help you because they have to do their own work. Okay, so here we have y equals 8x plus 2. That was already in this format. So y is equal your slope times the number x plus your y-intercept. This one is not because this is 2y. But what can I divide each of these numbers by? Well, I have a 2 on my y, so let's do 2. No, you can. So that cancels out. 16 divided by 2 is what? 8. And then 4 divided by 2 is 2. Now look at your two equations. This one, huh? That's it's going to be infinite solutions because you have the same slope, same y-intercept. You can either put the infinity sign or you can write infinite solutions. Now this one, we got the x and y on the same side. I'm going to break y'all up back there because y'all doing too much. This table. I'm not you in particular, but the table. Actually, I was looking at Marley. I wasn't looking at you. This one, we need to move this over here. Do y'all remember what I said when you move something to the other side? What do? Make it change, just change the sign. Yeah. So what? Let me just do it this way. You're going to add 5x to each side. Now we can't combine those because that 2 doesn't have an x with it. So y is equal to 5x plus 2. So I moved it to the other side. What happened to the sign? It changed, right? It changed to positive. So whatever if you move something to the other side of the equal sign, just change the sign. That's a quick step. So now both of these equations are exactly the same. So we got infinite solutions on that. What's your question about how to put these in slope-intercept form? Okay, number 8. I need to fix this one. So what do I need to do here? I got 3y, divide everything by 3. So then I'll have 3 divided by 3 is 1. So y is equal to 3x plus 3. Now compare these two. Slopes are the same. Y-intercepts are different, so it's no solution. Correct. Because it's 3y.
No, but the 6 plus 5, or the 6 and the 5. How does that?
What's 6 and 5? I didn't change this equation. I changed this one.
I think she's talking about like the 6 divided by the 3.
Oh, it's 2. I'm sorry. 6 divided by 3 is 2, not 3. Okay. It's still a no solution, even though your teacher can't divide 6 by 3. So now I got this equation and this equation. Same slope, different y-intercept. So it's a no solution. All right, come on, Leah. Now I'm going to go over one of these with you, and then I'm going to go over side 1. It'll say systems of equations number 1, and then you're going to do 2 by yourself.
Oh.
I think I've almost stopped saying simultaneous equations. That's what they used to say when I was in school, simultaneous equations. And I say that and people go, what are you talking about? But we still solve them exactly the same way, even though we call. So if your parents are old school or your grandparent is an engineer, just tell them it's simultaneous equations. Okay, so let's look at this one. Okay, everyone. Shh. Let's be courteous. We're on number 1. So on one side it says number 1, and on the other side it says systems of equations number 2. You need to put your name on both sides, but especially put it on side 2 because that's the side I'm grading. Shh. Okay, now let's look at part A. Let's look at the first one. We're going to either say no solution, one solution, or infinitely many solutions. So let's look at this first one, y equals 5x plus 12, and y equals 5x plus 18. So somebody talk yourself through it out loud, whatever you got to do it. Okay? So how would we determine how many solutions this one would have? Talk it out. To tell me how. Don't tell me the answer yet.
Okay, so basically the slopes are the same.
The slopes are the same.
So then it will be no solution.
Okay, because the slopes are the same, it would be no solution.
You also
It's
said
just
the
that
y-intercept. It's a y-intercept.
Right. So slopes are the same. Y-intercept different makes it no solution. Very good. Okay, so things stop right.
She's not done. Goodness.
Let's see if this one right. Okay, so none of my writing stuff is working.
It's a regular board.
It's no solution. I was on this screen, so that's why it is doing that. So when I switch to this one, it doesn't like it. But y'all know it's no solution, okay? Now let's look at the second one. Now remember, the slope is the number in front of x. So Donovan, what is the slope of this first equation here? -5? Right here. 5. Okay, what's the slope of the second equation? Donovan? It's not. Somebody's 10 is the what? Y-intercept. So what the slope is always the number in front of x when it's solved for y. So my slope is, somebody over here said it, 1. So I have a slope of 5 and a slope of 1. So that means it is a